Hi everybody, so today we're going to start with just a warm-up to help us understand and kind of review a little bit about ratios, a little bit about unit rate as we go into our lesson today on independent and dependent variables. So take a look at this one. And I want you to kind of try it by yourself first. Please don't watch me and just kind of copy because I know you guys know how to solve this one. So read through it. Feel free to use that 3-read strategy. Read it once, read it again, highlight anything that's important or stands out, and then read it one last time to make sure that you've gotten all the details, and then try to solve. At this time, I would suggest pausing this video, taking about 3-4 minutes to solve, and then playing it again once you're ready for an explanation. Okay, at this time, you hopefully should have had a chance to go through and try this example on your own. Let's go through it together now. So this first one here is saying, which one would you choose? Be prepared to explain your reasoning. And this is essentially a better buy question. You have 1 jug of honey here that's 5 pounds for $13.35, or you can get 3 smaller jars for $13.05. So just real fast, if I have these 3 jars, and this one's 1.5 pounds, and this one's 1.5 pounds, and the last one's 1.5 pounds, it means I have 1, 2, 3, plus my half is 4. I have 4.5 pounds total. So I'm just going to keep that in mind as I go through this. So I can essentially buy 5 pounds for $15.35 or 4 pounds for $13.05. Well, to help me figure out what's going to be the better buy, I want to know how much it's going to cost for one. So for this one, I'm going to take my $15.35. I'm going to divide it by my 5 pounds, and I'm going to find that it costs $3.07 per pound. For my other one, I can take my $13.05 and divide it by my 4.5 pounds. And I'm going to find out that it's $2.90 per pound. So I can say buying the 3 1.5 pound jars is the better buy because it costs $2.90 per pound when the 5-pound jar costs $3.07 per pound. Okay, and that's our first one. Just a quick review on unit rate using that division to help us figure out the price per one. Now, actually, before we jump into our next activity, because today we only have one other activity, we're going to take just a little bit of notes to help us explain some new vocabulary words. So at this point, guys, I would open up to the blank note pages in the back of your workbook, and we're going to go there. And I'm actually going to scroll down and see if I can find a blank page. Nope. Can I add a blank page? There we go. Here's my blank page. Okay. So once you're in the back of your notebook, we're going to be talking about 2 different vocab words. We're going to have an independent variable. I'm actually going to rewrite that though because we're going to make a T-chart. And I need you to have room to do it. So independent variable. And then dependent variable. So when we're going to be talking about equations today, we're going to have situations where we're going to see 2 variables. Oops. You can see we have a y here, and then we have an x here. Or in your problem, it could be a p and a q. It could be an m and an l. It could be an a and a z. I don't know. They can pick whatever 2 they want. One of these variables is something that we call the independent variable. In this case, it's going to be the x. And then the other variable is going to be the dependent variable, which is going to be the y. So let's start by explaining what independent means. It's a variable that represents the input of an equation. Or a function. Of a function. I'm going to write function. So for this one, it's the thing that you put into the function or equation. So here, usually I'm going to put in for x first. And another way that we can think about it, it's the value that's not affected by another value. Okay? So when I think about this here, y equals 6 minus x, the independent value is the thing that I'm going to be putting in first. And I can pick any number at all that I can do for this. So if I'm talking about this x, I could pick 2. 6 minus 2 is 4. I could pick 3. 6 minus 3 is 3. It's the number that I pick first, and its number is not affected by anything else. Now we're going to talk about dependent variable. It's the exact opposite. It's a variable that represents the output of a function. Okay, so we could also say it is the value that is determined by another value. So this value is determined by another value. So when I look at this here, y equals 6 minus x, y is the dependent. Put a little dependent. X is the independent. Y cannot be determined until I know what x is. So y depends on x. X can be whatever it wants, 2, 7, 3, whatever. And then y will be determined based on what your x ends up being. I'm going to drop just a couple links as well into the Google Classroom to show you more examples of this, of other people explaining it, so you can watch, and hopefully between all of those you get a good idea of what that's going to be. So now we're going to go back to our notes, and we're going to look at, hold up, my screen is not behaving. There we go. We're going to go back to now our lesson, and we're going to work on our activity for the day. All right, so now that you should have had a chance to open back up to our lesson, we're going to look at this activity. It says, Lynn needs to mix a specific shade of orange paint for the set at the school play. The colors uses 3 parts yellow for every 2 parts red. Complete the table to show the different combinations of red and yellow paint that will make the shade of orange that Lynn needs. So I want you to take a couple minutes and do this piece by yourself, because I know that you absolutely can do this. So take 3-4 minutes, pause the video, work through this on your own, fill each and all of those values, and then when you're ready, play the video again, and then let's match and see if we match. All right, everybody, so this table is talking about just a set of equivalent ratios. If I have 2 cups of red, 3 cups of yellow, it means I have a total of 5 cups. Well, next we're going to need to figure out some of these missing spots. And I remember from when we did ratios a couple units ago that I can use this relationship like this. How do I get from 2 to 6? That's times 3. So I'm going to take my 3 and multiply by 3, and then this value is 9. I could take 5 and multiply by 3 as well, and I'm going to get 15. Or you could have just added across. 6 plus 9 gives me that 15. Okay, my next value in my row is a 20, so I can figure out I can go from 5 to 20 by multiplying by 4. So 3 times 4 gives me 12. 2 times 4 gives me 8. All right, next row, I have an 18. Well, I happen to notice there's a 9 here. And 9 times 2 gives me 18. So I'm going to do 6 times 2, which gives me 12. And then 15 times 2, which gives me 30. Which again, I could have just added the 12 and 18. For my next spot, I have this 14. I'm going to do 2 times 7. So I'm going to do 3 times 7. That gives me 21. And I can either add these or I could do 5 times 7, which gives me 35. All right, for 16, I can see that I'm going to use the 8. 8 times 2. So now I'm going to do 12 times 2, which is 24. And then 20 times 2, which is 40. My next missing blank is a 50, so I'm going to do 5 times 10. And again, there's a bunch of different places you could multiply this. These are just the ones that I'm picking. So I'm going to get a 30. 2 times 10 is a 20. And then for my last one, I noticed 21 can get to 42 just by multiplying by 2. So I'm going to get 28, and I'm going to get 70. So now we have all of our values filled out, and our chart is complete. So our next piece we're going to work on now is this question 2, which is going to bring in that idea of the independent and dependent variables. So Lynn noticed that the number of cups of red paint is always 2/5 the total number of cups. Can you see that? So for example, here's the red paint. If there's a total of 5, she can figure out that the amount of red paint is always 2/5 the amount of total. So she writes an equation to represent that. She's saying R, I'm just going to write this a little bit bigger, R equals 2/5 the total. Remember where R is the red and T is the total. Which is the independent variable? Which is the dependent variable? Now explain how you know, guys. I have like one itty bitty little line, so I'm not going to write out my explanation, but I'm going to talk it through. So I'm going to say my independent is the T, the total amount. Based on the equation that she wrote, R equals 2/5 T, you have to input T to figure out what R is. So T is independent. I can put anything I want in for T, multiply it by 2/5, and then I'm going to end up getting R. So then my dependent variable is our amount of red. R is dependent because it's what the equation spits out at the end. Once I do 2/5 times T, then I can figure out what R is going to be. So now they want us to do a similar thing, but now we are going to write an equation that represents the relationship between R and Y. Well, R and Y are talking about red paint and yellow paint. Now they're telling you they want Y to be the independent variable. So we are going to be multiplying or doing something to Y so we can equal R. And we're going to have Y and we're going to do something to Y to equal R. Let's take a look at this. My yellow paint's always 3. My red paint's always 2. So my yellow to red is going to give me a 2 to 3. Whatever I get for yellow, I multiply it by 2/3 and I'm going to get red. So let's take a look at this. 3 times 2/3, well, that's 6 over 3, which is 2. Not this one. 12 times 2/3, well, 12 times 2 is 24, divided by 3 is 8. How about 30? 30 times 2 is 60, divided by 3 is 20. So that's our equation. Okay, we have one more equation that we're going to write together. As soon as I find my page that disappeared on me, there it is. Okay. Write an equation that describes the relationship between y and r, but now r is the independent variable. So now we're looking at this, but we are going to be switching it. We want y to be the dependent, and we want r to be the independent. So you can switch this. Now, because I switched this, I'm actually going to switch my number I'm multiplying by as well, my 3/2. Again, you can determine that by looking at it. If I take 20 and I multiply it by 3, I get 60 divided by 2, it's 30. If I take, let's do 12 and I multiply it by 3, that's 36 divided by 2 is 18. So that relationship's working as well. Now, the last thing that they want us to do is they want us to actually graph what we have just seen. So for this one, they want you to do cups of red on the bottom, cups of yellow on your y-axis. So for cups of red, I'm going to have to keep scrolling back up to see this. I had 2 and 3. So 2 red, 3 yellow. Okay, for my next one, I'm going to have 6 red, 9 yellow. 6 red, 9 yellow. For my next one, I'm going to have 8 red and 12 yellow. 8 and 12. After that, it's going to be 12 and 18. Then I get 14, 21. Then there's 16, 24. Then we have 20, 30. And then we have 28, 42. Here we go. Okay, and then which equation was this one matching? This one was matching the y equals 3 over 2r. Because I was putting the red first, that's what I was in first, and I was getting out y. Put the red in first, multiply it by 2/3, get the y. Now we're going to do the exact opposite on this one. The one we're going to start with yellow and then move to red. So for yellow, I had 3, then 2. For my next one, I had 9, then 6. The 6, I can't see. This is a little, very small. Then there's 12 and 8. 18, 12. 21, 14. 24, 16. 30, 20. And then 42, 28. 42, 28. There we go. And this time, because I was starting with the yellow paint, that means that my yellow paint was my independent variable. So that matches r equals 3 over 2 y. But not 3 over 2. That's why. 2 over 3. I was looking at this. I'm like, that doesn't look right because it's not. 2 over 3. All right, guys, if the equation parts are still kind of confusing you or being able to kind of write that equation, don't worry. We're going to do more of that on Monday. The biggest thing today is just to understand conceptually what does independent mean versus dependent. All right, that's all for today, guys.